So, welcome everybody. Welcome to the CDM Ceph Developer Monthly meeting of November. So, I was just checking the planning document, and we have a couple of topics to discuss tonight or today. It's the meeting on APAC hours, so it's a night for us here on the side of the planet, and a day for Brad and other people in APAC. So, Greg would like to start, or Mark, Josh, how do you prefer? Keep the order of the list?
Sure. I can
go.
Okay.
People's
Okay,
actually
Sage is here.
lower by the time we're at the end.
Yeah. So. Yeah. Hello, Sage.
Hello, can you hear me?
Yeah, pretty well. We just started the meeting. I mean, no one started talking about the topics. So if you want to mention something before starting, otherwise we can. I think we can have Mark and Josh talking about.
I think Josh is gone. I don't think he's not here, is he?
Hmm.
He's on PTO.
Oh, I see.
So I think it's just us. Mark, are you here?
I am here.
All right.
Hello. So
Greg. Okay. Yep, let's do it.
Okay. I also noticed that Halmai is here, which I'm really excited about because when I was looking at kind of looking into this PG log issue, I noticed that there was an email exchange between you and Sage and Halmai from 2015 when we were repeating almost the same conversation here about NewsStore and how we should deal with PG log data. And I think we were bushy-tailed and bright-eyed at that point, hoping that that we'd be able to make RocksDB just kind of behave well. And I guess maybe we still can, but let me see. I think I actually managed to just pull that up here. So I'm going to post it in chat to remind everyone of what that was. But so for those of you that are here that didn't see my post on Ceph Devel, the gist of this is that when we do small random writes, especially in BlueStore, but potentially in FileStore as well, we're causing all of these key insertion and deletion events for pglog and dupops, and maybe pginfo to a lesser extent, but definitely pglog and dupops. We do all of these key inserts and deletes, and on spinning disks it doesn't really matter because we're so slow anyway at random writes that the workload is kind of not trivial, but it's a lot less complicated. This is when we're on like Flash that this is kind of a big deal, and it's not just the write amplification overhead, which is part of it, but that's not necessarily the big thing. It's that there's CRC checks on all these keys coming in, and we're recomputing the Bloom filters, and there's potentially other maintenance stuff just getting through the skip lists and mem tables and in RocksDB. So there's all this extra memory overhead and CPU overhead and just general mayhem going on dealing with all these keys. And so I talked to Josh last week about this, and kind of my naive first take on it was, well, why don't we just throw these inside some kind of like ring buffer, essentially on the flash device, and just kind of write keys out until we run out of space and then start it over again. Sorry, not keys, but like PG log entries. Just kind of do away with the concept of min and max and just write out as many as we can until we can't and then loop over again. Josh pointed out a very good point that you can't really do that. You want inactive PGs to keep their records so that we can go back and get them again. So you can't just do like a straight ring buffer. You have to do something more clever, like write out sequentially allocated chunks of space that then you associate with each PG, and then once it kind of falls out of scope from every single PG, then you can get rid of those things. So you could do something like that, right? It's kind of like the RocksDB write-ahead log, the way that works, except that you just make it keep adding them until they you can finally get rid of stuff, right, and then recycle it. So it would potentially could be big space amplification, but the benefit would be that you'd only ever write once. You'd never do any kind of compaction ever on it, and you could bound it based on how many PGs you have and how many you keep around and stuff. But
so
go ahead, Sage.
The big trade-off is that you then have to do an additional I/O for every update operation, because you have to do an I/O to append it to the per PG log or whatever, and then you have to do your transaction commit. So you have 2 I/Os. Whereas if you put it in RocksDB, then you have 1 I/O, and then later after you do like 100 or 1,000 of these, then you have one big write of the compacted stuff.
So I think one of the questions I would have is all of that overhead that we have for doing the compaction and everything else, is it worth it? I don't know. Yeah. But okay, so that the thing I just described is one way we could go, right? That you could do like an on-disk thing like that.
A little bit on what the costs are, Mark. I see that you have some numbers about I/O on this email you sent to the list, but I have not spent a lot of time in RocksDB, so I only sort of can guess what they mean. But you're talking about CPU time here too, which I don't see anything about in the written document, and
yeah, that's
I just don't have a good sense for what this costs us, because I don't have any context for what the numbers mean.
So it depends on a number of things. It depends on kind of how fast CRC can happen, and that has been kind of problematic because we aren't always using the CPU acceleration or like the SSE4 acceleration in RocksDB. That hopefully is fixed now. But even with that though, just in some numbers that we saw recently on a Flash-based OSD, there was like 20% of the CPU time spent just in CRC calculations, and then more time spent doing other stuff. I don't know actually how fast those CPUs were, so that might be kind of BS. But
it's a little bit.
Sure, but I mean, we're going to be doing CRC anyway, right? So what's the proportion of time we're spending on PG logs compared to other stuff?
I don't know that there's a good number. The anecdotal information we have isn't super satisfying, but it's that the KV sync thread, which is the thread that's actually submitting these into just doing the inserts into RocksDB, is basically saturating the core. So there's one CPU that's doing nothing but inserts. And a lot of that time is when Adam was going through and profiling it is CPU stalls because of memory prefetches, because it's traversing this huge skip list trying to, the in-memory mem table is like a sorted table basically. And so each of those inserts, the key comparisons and fetching all the whatever and putting it in the right slot, it's just too much memory that it does a lot of stalling.
Okay, so which makes me think not even that directly this is expensive, but that we need the overall load to be lower, and this is a possible way to split it out.
Yes.
Okay.
And yeah. I suspect, I don't know for sure, but I suspect that if we split this away from RocksDB, we could make the mem tables a lot smaller and make the write-ahead log buffers a lot smaller, because we no longer have this ridiculous key insertion load happening, right?
That does mean, though, that we're not getting any sort of I/O aggregation, right?
Right.
Does that also seem pretty expensive? If we're making every I/O take, I don't actually know what the number is, but take 3 random locations instead of 1.
But I don't
Yeah,
think
I mean,
we
the
want to do this
SSD
on
is going to
training just to, yeah.
do it, basically. Just pushing it off to the SSD. I mean, the thing is, it'll be a short-term win because we're not saturating the NVMe. Long-term, it's not the right strategy, right? We want to do something more clever where we're...
Well, long term, don't we expect with Flash that we're going to end up with like huge? Well, yeah, that too. But even midterm, don't we expect to have like huge parallelism to like multiple kind of areas on the Flash where we can do IOs to multiple places, but trying to kind of, if we can parallelize it, right, we can kind of get like free IO out of it. Not exactly, but
I would
guess
not expect that to happen. And yes, it is a thing that could theoretically happen, and that people have wanted to have said is like coming real soon for 8 or 10, like basically as long as we've been using NVMe. But no one wants to build the actual interfaces and do the management that requires.
Well, I mean, these NVMEs have a bunch of channels, and you have to have like a pretty deep queue in order to actually saturate them. Yeah. And we're not getting there, right? So
yeah, exactly.
Yeah, so it could be that just does it, but it's not going to be doing the scheduling directly.
Okay, so,
only by giving it something friendly to that multi-channel stuff.
So the other proposal here is, instead of doing something like this, we implement a ring buffer inside RocksDB itself, right? So this was kind of Josh's idea, that instead of having this on disk thing, log or journal or whatever, you have inside RocksDB per PG, you make a ring buffer and you just go through it and never insert or delete keys. So maybe it's a prefix plus just like a small, like 8-byte like index, and then you recycle through them.
I mean, I'm wondering at that point, what's the value of having it inside RocksDB?
Then right, you get the shared write-ahead log, right?
Yeah.
But then we're still doing all the CRC checksuming and everything. I don't see how that reduces the total load. And more than that, we then also need to be able to correlate these randomly named indexes with these randomly named keys with the correct PG.
Well, so that sounds like it'd be equivalent to having a column family for every PG, and that column family is in FIFO mode, so that RocksDB just sort of throws out the old SSTs as they come.
You don't want a column family for every single PG, though, because once, let's see, how does this work with the write-ahead log? Once any one of those column families needs to,
once you retire,
you have to lock the that particular log, right? You have to flush it.
I mean, you're writing out your log. You switch to the next buffer, and then the old buffer, in order to flush it, it's going to basically like write out the SST for every PG. That's what'll happen, but they'll be smaller. I think actually, if RocksDB were tuned such that as its first comparison, it checks to see if the key that you're inserting goes at the very end. Like you have some hint that says that usually my inserts are at the very, very end of the column family, then it would be a single comparison. Oh, it's past the end, and so I'm just going to put it there. So you avoid touching all that memory for the rest of the mem table or whatever. Then that might actually do it.
Greg, to address one. Maybe, but to be honest, I'm nervous that it's not going to work like that in practice. But one thing I did want to address, Greg said earlier, is one thing that this does buy you is that you're not trying to recompute the Bloom filters for all these like short-lived keys that are coming in and then getting promptly deleted. Because it looked like in a workload we saw recently that was happening. You're spending a bunch of time recomputing Bloom filters because of all these like keys coming in.
We can disable, even with what we have right now, where all the PG logs go in one spot, we could just turn off the Bloom filters on that column family.
Do we ever need to check for the existence of PGs on a regular basis?
Yeah, only on like peering and it's like pretty infrequent.
I mean, it's only on boot, I think, that we even look at them. Because otherwise,
Yeah, you're right, actually.
the memory
Yeah,
while
it's
we
just
have
all
it.
memory.
Like, yeah, it's all memory. We only use this for persistence, so we only read them on boot.
Yep.
Yeah, so okay, we could turn off the boom filters then for those column families. If we can separate out PG log from the rest of OMAP in terms of column family, that would probably help. I still wonder. Go ahead.
I was going to say you can dynamically create and remove column families to the running database, so that you could do that as collections or PGs come and go. You can dynamically set up the column family for each one.
I'm not sure that column family for each PG seems wise. I mean, maybe it will work okay, but
yeah, I don't know. Yeah, I mean, it might be worth a try.
I thought I heard at some point that they were talking about like single-digit number of column families.
Yeah,
was the recommendation from upstream. Although I just heard that secondhand, and so I have no idea.
I've heard the same thing.
It makes sense. We're talking about like double-digit number of column families, like 100 PGs per thing. It means that for every time you like flush an SST, like a wall log, mem table, whatever you call it, then you have like 100 different SSTs to write out. That's kind of a lot.
And that sounds like it would be, I mean, not that it matters right now, but eventually that would be pretty bad for our tail latencies.
Like it almost seems like what we want in order, so that it seems like the main factor that's like making it expensive is that the inserts have to like are keeping it sorted in memory, and so they have to like do this login search that does all these memory misses. Like that's the main thing. If there's a way to like have a hint or a cursor or position so that like it doesn't have to repeat that for every write to the PG, like that would be the thing, because we know that for each PG it's always going to be at about this specific spot, right? It's always going to come right after the previous key insert for that PG.
And this also has the big benefit that I really don't want us to have different things for flash versus hard drives. And there's no way we're going to add a new write aside area on hard drives. So.
Yeah.
Is it plausible to you, Mark? Does this sound plausible? That we could split it
I don't know.
Family and tune it?
You know, maybe.
I mean, it's already a separate column family, right? We all the PG logs together in one column family. That already happened. So it's just a matter of these like 100 fingers in the pile so that they insert in the same spots. So
Sage, is PG log in a separate column family right now from the rest of the like dubops and everything, like PG info and all that, or is
it's all of the internal metadata is in one column family. So it's the PG log and the dubops together.
Okay.
It's split out from OMAP?
It's split out from the rest of OMAP, yeah.
Okay.
Which I think ought to be fine, because it's all the stuff that we never read, right? So we can basically tune the compaction so that they're like 100 level 0 files or something. I don't know. Like there should be a way to figure out how to do that so that it's like more efficient.
We probably want to keep PG log at just one level, right? We just want level 0 and don't want to actually move anything into like level 1 ever.
Or at least rarely, right? If when it does its level 0 compaction of like 10 SSTs or whatever, almost always the keys have been deleted. It's only the ones for like the stale PGs or the PGs that have very little traffic or whatever that end up in level 1. So it's just like very cheap operation. But
right now the mem tables are huge, right? Because we've got 256 megabyte.
So I think that's the other problem. Like the reason why it's so expensive to like put that in the right position is because it's a huge table that's like can't get all the indexes, internal nodes or whatever, the tree into the CPU cache. So it's like a miss every time.
But that's again goes back to the problem of we have the huge mem tables, right? Because it's actually reducing the write amplification significantly right now.
Right. But perhaps we should reevaluate that. Like it might be better to pay the write amplification since we're not saturating the device anyway,
Well,
and
it has
big CPU.
It has not been so far. It's like more keys end up leaking into level 0 that it then compacts and is dealing with is what the compaction stats make it look like. So we're doing like more work overall.
Mm-hmm. Okay, well let's set aside the PG logs. I was kind of hopeful about this, but Josh is totally right. I forgot that they don't all trim in unison. Some PGs might be 100% idle, and you don't want to like go prune those logs. Probably, although maybe you do actually, right? If we're talking about like time synchronized trimming, but whatever. Set that aside for a minute and talk about the dupe ops. That is something where like a strict first in, first out, like ring buffer is like all you need, because you just want like a window of history to back in time to eliminate dupe ops.
That's exactly what we were talking about too. Is that's the case where you could just shove everything into one big ring buffer, wherever you want to put it.
Yeah. Because I wonder. So the thing that's cool about the FIFO compaction mode or whatever is it when it comes out of the write buffer, it writes the new SSD in level 0, and after there are n of them, it just deletes the oldest one. It just throws it away. So it's totally non-deterministic when it goes away. You don't know. It's not like Rockspeed tells you that it deleted these keys. It's just assumed that it's a workload where you persisted it, but you don't really care how far back you can read exactly. And I think that's actually a case where it might be that the dupe ops that we have in memory, it doesn't actually matter if they correlate to what we wrote down on disk, because the only time we're ever going to read them is if we reboot, right? Or if the OSD restarts. Do we care if it doesn't, if it's not the same? You know what I mean?
Yep.
It's still a window into the past. We'll just load as much as we happen to have persisted and Rockspeed hadn't thrown away yet. In memory, we'll have some trimming policy that's like, hopefully on the same order of magnitude as what Rockspeed is. But even if it's not, I think it wouldn't matter.
So
Does that make sense, Greg?
Yeah, I think it does. I'm just trying to think through the restart, because it's possible that that's when we'll actually have stuff getting resubmitted, but I think it's okay.
Yeah, and we'll just have however much.
As long as the FIFO queue is longer than
what we want, what we need. Yeah. Yeah.
Is the FIFO compaction mode actually stable?
I believe so. If you look at the doc for it, RocksDB, there's a thing at the bottom about FIFO compaction with TTL. That's a separate section. And that part says it's a new experimental feature. And, be careful. But the regular part about FIFO compaction doesn't say anything like that.
Okay.
It says it's the simplest compaction strategy. It's suited for keeping event log data with very low overhead. Periodically deletes old data, so it's basically a TTL compaction style. It says use with caution. You can drop data without informing users. So you can use it for certain things.
I mean, we could try a like huge number of individual column families, one for each PG, and try it with the FIFO compaction.
Well,
I suppose.
what I would be inclined to do is do this just for the dupe ops.
Mm-hmm.
For the PG logs, I don't know if we can get away with it. It would, I guess. So assuming we were writing out, we are writing them out in time order, so it doesn't really matter. Mm-hmm. But assuming we were like, I mean, what would happen if, so say in memory you have, the last 2,000 log events and you're going through peering and you're doing all your stuff or whatever, and then you crash. When you come back up, peering like requeries you. It doesn't like remember how much log you had before. It doesn't strictly care. It just asks you when you come back up, right? And when you come back up, you're going to look at your FIFO table. You're going to read the log. You're going to figure out how many entries you have, and you're going to you can adjust your log.bottom or log.tail or whatever based on that. Like, maybe it doesn't matter. Like, it might even just, it might just work without actually changing anything to put the PG logs in that kind of queue.
Oh, well, you're right about needing to set the tail, though, I think.
Yeah, right, yeah. So on read log, you'd have to see how far back your entries go and adjust.
That's actually, that is part of the primary calculation and stuff too, is who's got the overlapping tail.
Yeah. But there's no memory between OSD restarts. Like peering gets retriggered in a new interval, it reprobes everyone.
Yeah, I think so. Yeah.
It would be a little bit weird if the in-memory trimming is no different than the on-disk trimming, but it doesn't actually matter. It's sort of weird. So that might be an easy experiment to run, actually. So I think actually you could run unmodified code without changing it because you just don't reboot the OSDs. So Mark, you could just change that column family. It's called I can't remember, P, I think, for the PG metadata. Just change it to do the FIFO compaction and see if it makes any difference.
We would, okay, I see.
Although actually, in order to see whether it helps, we would just basically comment out all the lines that delete the log. So the trimming, whenever there's a trim log, we would just not bother updating the database. We'd let RocksDB do it, right? We would just trim, we would trim the in-memory part, but not bother deleting. Same with dupops. We wouldn't bother pruning the old dupops. So I guess we'd have to change a little bit of code, but that's just a few lines of comment out. That gets rid of all the deletes in that column fam, or we're just doing inserts. Unless there's a big pairing event, in which case, whatever.
We would need to also then get the boom filters off of that column family so that we can see.
Yeah, so I guess those would be the two options. Two options to set on the column family.
So I'm trying to think through what the ramifications of this versus the ramifications of something like the kind of ring buffer inside RocksDB would be, in terms of things like how much data is being transferred as part of the key.
I mean, it's basically the same thing, except instead of literally overwriting the same extents on disk, it's just allocating new files and deleting the old ones, right? Functionally the same.
No, I mean actually inserting new keys and letting RocksDB delete them versus reusing the keys inside RocksDB. That's what I'm wondering. Does that make sense?
No.
So, okay, right. Okay, so say you've got a set of keys, ordered keys that you're using for a ring buffer inside RocksDB for a given PG, and you reuse the slots. So
you reuse the actual same key name?
Yep, reuse the same key name, and it's a small key name based on just an index essentially, and a small prefix.
Right? I don't think it matters.
How much?
RocksDB doesn't care what the key names are.
Well, it matters a little bit, right? Because we do encoding on every single one, and it at least has to figure out what part of that key is a prefix and go through it. So I imagine key lengths are going to have some
short
of that.
Keys would help certainly.
And right now,
we could do that.
How long are our keys right now? Are they big?
For the PG log entries, they're kind of, the OMAP prefix is 8 bytes. And then the actual PG log key name is probably I think it's in hexadecimal or something. So it's probably 16 bytes or something. we could have that size. And then there's the like 100 odd bytes of the actual pglog entry.
Yeah.
But it, I mean, yeah, I don't think that. I guess so. I think the first thing to try is commenting out the deletes for the trims of the pglog and 2 pops, and set the comp family to FIFO and bloom filters off. And just see what happens. See how much of a difference that makes. But I think the real win is probably to change the figure out if there's a way so that if we know we're doing successive, the same writer is doing successive inserts, if it can like have a cursor or something or a hint. Kind of like when you do an STL map insert, you can give an iterator that hints where you think about you're going to do it. If there's something like that, I think that would help. But that's a question for Ply, Adam, and Radic, since they've been going through the RocksDB code. No, they're not here because it's middle of the night there.
Yeah.
3 a.m. or something. Okay.
I guess generally the only last comment I'll make is it still feels like we're kind of trying to kind of bend RocksDB to our will here. And
yeah. Well, I think from a practical matter, that's our only real option for BlueStore. I think that once we do a bunch of CSAR stuff and we've sort of improved the rest of the stack and BlueStore isn't sort of the slowest bit anymore, then I think we're actually going to have to write just a different thing that's like written for pure NVMe, and it's different, right? It's going to be like log structured. It sort of does its own cleaning. It doesn't encode and decode keys, but the in-memory representation is the exact same thing as the on-disk representation. So it could be M-mapped or just like copied without doing any marshalling or whatever.
Yep.
Like I think that's what we have to do.
I agree.
Just bite the bullet and yeah, do something even more ambitious. But,
so now that you're in your new raw block device access, you want to write another one?
Yeah, pretty much. Well, no, I want to wait a year and a half and then do it. but I think that's what's gonna. I think that the thing that's gonna like always kill us in BlueStore is the fact that it's using a key value database with like sorted keys, and everything has to be like encoded and marshaled, and it gets copied like 12 times. I think it's just not gonna. It's not gonna cut it for the fast NVMe stuff. It does okay for now, but only just.
It's going to last a lot longer than our protocol does, I think. So we'll see.
Yeah.
You don't commit to that too much in your head yet, though.
Yep. Yep. All right. Should we move on?
Sure.
Okay, so brief update on the snap trimming. We don't have to go into this too deep, but I just want to bring everyone up to speed. I realized that the fundamental problem is that for clones that exist, there's the clone with the name that's one of the snaps it was originally defined for, and it has a set of snap IDs that it exists is defined for, and SnapMapper indexes those. So whenever we delete one of those snapshots that is referenced by the clone, we go and we clean it up and we update the clone metadata, we update the snapshot, like everything's fine. The problem is the snap sets for objects that haven't been cloned yet, or for updates that are recent enough that they haven't resulted in a clone, they're also a set of snaps stored in a snap set. And we don't touch like every head to see if it is defined for those snaps, and we don't index the head for the snaps that haven't been cloned yet, and so those don't get updated. That's the basic issue by the trimming, and we use that in a couple of places, but they're annoying places. It's used in cache tiering for doing flushing and for promotions in order to like wrangle and creep around and try to like make it so that we have just the right crafted rate of stop so that it results in the clone that we want. That's pretty much the only time it's used where it matters. The other place it's used is when like a request comes in. If the request comes in with a snap set that's like version 10 and some snaps, and the on disk head has like snap seek 12, so it's a slightly newer set of snaps, then we use that one on the request as when we process it. But we can get rid of that, because if we're doing that, if the snap seek that's already on the head is newer than the one that we submitted, we're not going to clone as a result, because the object on disk is already newer, so it's not old enough to result in a new clone. So we don't need to know what the snaps are, because we're not going to clone and have to use those snaps. So if we get rid of that, then it's just cache steering, basically. That's a pain in the butt. And we can't fix that easily. Even if we could, even if we knew exactly how to change snap tiering right now, we would have to still keep maintaining that snap set snaps for 2 versions so that the upgrade paths work. So what I did instead is I did almost everything that I was doing before, with the objector updating requests a little bit more sanely, and with the monitor publishing the newly deleted and newly purged stuff in each OSD map and whatever. So all that stuff's there. And so all the data structures that are traversed for handling removed and then purged snaps are all per epoch, and they're all incremental, and they're all small sets. And so all the like gross CPU wastage that was happening before, that were having optimized, that's all gone. But the removed snaps with all snaps deleted for all time is still in the OSD map PG pool thing for the time being. And so I'm thinking is that we do that first bit so the pruning is more efficient, and so we make the problem a little bit better. And then hopefully if we can like buckle down and do it, we can change the way that cache tiering does the snaps and promotes, the flushes and promotes, so that it doesn't rely on that. I think if we just make it so that when we flush a clone, instead of flushing to the head in such a way that the next write will cause it to clone, we just flush directly to the clone, or flush it and force a clone so that it happens immediately. I think if we do it that way, then we can get rid of the other thing. But in order to like really, when we have to do that piece also and get it into Mimic, so that by the O release, then we can like get rid of all the other crap.
So I followed your conversation, although I wanted to go read your email. I haven't yet. Why can't we just filter the snapsets we read off disk for ones we know are deleted?
Filter the snapsets we read off disk for the ones we know are deleted, because we won't know what the deleted ones are, because we don't want to have a history of all snapshots deleted for all time. And the head can be arbitrarily stale. Like you could have written the head like 2 years ago.
Right.
And then you come in.
Okay, yeah. I got it.
Yeah. The other thing we could do is sort of the annoying thing where every OSD does have this all snaps deleted for all time data structure sort of globally. But I just don't like that. I just don't like it because it still feels sort of broken. It might be strictly better, I guess, than what we have right now, but it's not like the best thing.
Yeah, and I was thinking down that path and never managed to come up with a good way to know whether we were covering the ranges or not. I don't think we can actually. I'm not sure it was actually possible. Although I didn't disprove it, I just couldn't really do it.
It might. That part might not be so bad because if you have incremental, if you process the whole full sequence of OSD maps, then you have it, right? Because each time you get an OSD map, you update the set atomically.
Well, yeah, but I mean, you don't want to keep it in memory and run a comparison on it.
Right. Yeah.
Because otherwise, we have the same problem we have now. And so I was thinking that you could, like, in our email thread at some point, I was talking about, like, well, you could probably just, like, know what range of snap sets your deleted set is valid for, but I don't think that's actually possible.
Yeah. because they don't correlate with time.
Yeah, exactly.
It's like it's the delete time that matters, not the create time. Whatever. Yeah. Anyway, yeah, that's that. That's that first bit. I missed something with the way that I was trying to get rid of some variables, whatever. I'm still debugging the stupid thing, but hopefully that part will get in. And I'm not sure if I'm gonna like have it in me to deal with the cache sharing thing, just because like I don't want to mess with cache sharing at this stage. But we might have to, because
Yeah. So
either
can you
we just
explain again how you? So we use the snapsets to make sure we get all the appropriate like clones. So how are you saying that we can do that better? I didn't understand.
So the two cases are when you flush the head. What happens right now is we look at the clones that are on the head.
Yeah.
Or sorry, when you flush the clone. So you're in the cache tier, you have a clone, and you're flushing into the base tier, but the base tier predates that clone.
Yeah.
And so when you flush the clone, you create a snap context that will generate a head in the base tier with the right snap C, or with the right snap set, so that the next write after that will force it to clone exactly the same as the clone that we're flushing in the cache tier.
I don't think it's extra IOs, which is what it sounds like you're describing. It's just that we do each write back in time from when the write happened.
So that's what's happening now. But right, and so that's fine. That's the efficient way to do it. The problem is it relies on the base tier remembering the snap sets.
Okay.
In the head, or actually, I guess it's the next write. I can't remember exactly, but basically needs to know those snaps. That's one of the two places where the snaps vector in the snap set is used. I'm blanking exactly on why, but I think if we change it so that when it flushes the clone, it like sends an operation that actually makes it become the clone that is in the cache tier with the same exact information, then we don't have any dependence on. We don't care what the snaps are on the head, right? We just make the same clone.
Yeah, it's just interface shattering, right?
Yeah, it sort of hides the cache tier pretends to be like a client, but it kind of cheats. There are all these special flags that the cache tier uses when doing its write back, so it isn't really.
Well, but I mean, it's sort of the flags all make sense through the layers, whereas this one is like reaching directly into the disk data structures, which is not totally awesome.
I mean, it would be a flag that's basically like, this is a clone, and we would like have the fields in the snapc like somehow map directly to what the clone should look like. It's a little bit goofy, but it would work. It would get rid of that dependency. And then the other half is when you have if you have a series in a cache tier, you have a head and a bunch of clones, and you evict the oldest clone, but then you want to promote it again. That promotion, I can't remember why. There's some reason why that promotion has to look at the snaps also. Yeah, I can't remember why, but there's another thing there. But I think they could be fixed with making cache sharing a little bit more low level than it is already. But the payoff would be then that we can get rid of the snaps vector and snap set, and all these sort of headaches go away. So.
And the reason I get rid of it is because when we do the flushing, then it is marked as existing for stale clones. No, except it's not, because the.
You have to go. If you.
I was just saying, I can see if there's like logic in there where like when the cache is flushing it down to the base tier and the base tier doesn't accept the cache tier's like snapset, and it kind of builds its own snapset, that on promotion back to the cache tier, it's got to kind of have to merge back in what the base tier really says the current real life snapset is.
So it's in finish promote line 8300 in primary log CC.
But we all know that logic is probably buggy anyway, so I don't know if it's.
Yeah. Oh, I know what it is. Okay, so it's the converse. It's where, so we had the oldest clone and we evicted it. But remember, when you're evicting, or when you flush a clone, you're flushing it to the head, and then such that the next write will clone it. So if we flush the oldest clone and then evict it and then promote it again, when we try to read that clone, we're actually reading from the head in the base tier. And so we're again relying on the base tier's set of snaps stored on the head in the snap set in order to know when we promote the clone what the set of snaps are that it should be defined for. That's why.
Oh, I guess I didn't realize the cache tier could promote clones or it could promote the head. It didn't promote the whole like history of the object. Like you actually just have the specific like snap up.
It has to. It has to have the head before it has anything else, and it can only have it.
But it can flush out.
But
it can flush out an old clone. It doesn't need to flush out the entire like history of the object.
Right.
I didn't realize that. Okay.
Yeah, it can evict just the oldest one, and then
it's like there's this long-standing bug with like cache tiering and clones and diff sets and things like that. So it's like
for non-existent. This looks familiar. Yeah,
I box, and it's something I want to go look to them about, but I've never had time for.
Yeah. Anyway, so I think it could be fixed, but it'll be gross. But my sort of long-term goal in my head is to make the new tiering have enough functional parity with cache tiering that we can get rid of cache tiering, and all the like ugliness that comes from having this like not actually knowing whether the object exists or not when you're doing the IO.
So short term though, like what is the use case where you'd actually want to flush out an old clone and not flush out the rest of it from the cache tier?
You have to.
I mean, it's a very specific use case, right? Like you're doing RBD that's doing a lot of snap creations that you.
Yeah. Well, no, you want to. The flushing has to happen on the oldest clone first because of the way that the write back works.
Yeah, no, I understand that
has
part.
to happen.
But why not just flush back from the oldest clone all the way to basically head to simplify the logic?
Like one operation, all of one big IO. Because it's
not one IO, but you basically, I mean, you have the way that the messaging layer works, you're gonna have to do it in separate IOs, but like why not just basically say like, all right, I'm flushing it back, so
yeah, I mean we could, I mean that would, but it's always like, since it's in pieces, you still have to deal with the idea that only one piece worked. But I think if we would just go directly to the clone instead of going to the head and having implicitly make it so that the next write would cause the clone that we want, we just write straight to the clone, or have that happen with the IO. I think that solves that problem.
Okay,
and as far as the eviction,
it's not actually these details that really matter, right? It's the problem is that the snap set, if the head is old, the snap set might identify snapshots that don't actually exist anymore.
Yeah.
And so that's the thing.
Yes. But as soon as we fix this, we can get rid of that. We can get rid of that.
I mean, yes, okay, but that's.
Yeah.
But you're saying fix it in a way that you put a special flag on it that says I can overwrite a clone, or write a clone.
It makes it so that when you flush a clone, the base tier actually gets the clone instead of the head.
A head, no.
Within like a fabricated old snap.
Okay, but it's not. That won't allow you to overwrite a clone. It would just be if the clone doesn't exist. Okay.
Yeah, it'll just write. Yeah,
I mean, might it just be easier to add to when you to put heads in the snap trimmer index so they update the snap set?
That would also work. It just makes it
simpler.
It does.
In my head.
It means it's more work. Right now the snap trimmer only has work if the snapshot actually contains data. Yeah. And if we did that, then it would be order the size of the data set instead of order the size of unique data in that snapshot.
That's true.
So.
No, that's not right. Is that right?
Yeah.
Okay.
Because right now it's indexed only the clones that exist for that snapshot are the ones that you have to look at. And if we included the heads too, then any object ever written that like, or I guess recently written since after that snapshot was created.
Well, no, it won't be
will also
anything.
have to be
It'll only
examined.
be the ones that actually were written with that snap as part of their snap context.
Yeah.
Like,
Well, okay.
like
So
for
if you
RBD,
have
they're all
1 terabyte,
snap IDs, right? So
say you have 1,000 objects and you create a snapshot on it, then you have to examine, and then you write them. You have to examine those 1,000 objects. And once you create a second snapshot and write, say, half of them, then half of them will be in the first snapshot. The new half will be in the second snapshot.
yeah.
So it's sort of like, whereas right now, you sort of get everything new is free.
Yeah.
I guess it might not be as bad, but I would rather get rid of that field so that we don't have to, it doesn't have to be accurate and there's less bookkeeping we have to do.
Say, wouldn't that be bad for the RBD case where really it's pool wide, you have snapshots, so you have to iterate over all objects?
Well, no, I mean, that's what I'm saying is that no, it's only, the data
just the
only
ones
goes
for
in
that
the
image.
snapshot if that snapshot was used in the snap context. So you'd have to look at every object in the RBD that
Image.
whose snapshot you're deleting.
That was updated since the snap was created. Yeah.
Which is
kind of what you would expect, actually.
yeah.
We've sort of gotten away with not having to do that, but
Now it may be that is expensive enough that we don't want to do it, but I also like not having to make protocol changes.
yeah. Well, I mean, this case would be the write back would work both ways, right? And I think the long term plan is to get rid of cache steering, and so this would be like a little bit more of ugliness and debt on this thing that eventually we're going to rip out. And the upside is that the thing that we're going to keep, which is the snapshot, is simpler.
A flag around for forever.
Yeah.
Like the new ops.
Yeah. That's comparatively cheap. It's like frustrating when I realized that the snaps field was in the snap set and like there's all this work being done to like keep it up to date, and it was like almost not used. And when it was used, it was like totally unclear why it was being used and whatever.
Well, I mean, you're saying it's cheap, but actually what you're like the way it's going to plug through the layers, it sounds more like the level of the clone range command, which was a pain in the butt.
Mm-hmm.
Maybe not. You've thought about it more than I have, so maybe not. But it's not an op I'm eager to add to our repertoire.
Yeah. No, it's yeah. Yeah, I'm not sure exactly how it would work. I have to go look at it more closely, but
multi-level snapshot IDs. So you have one snapshot super ID per image in RBD, and then
yeah. Yeah. Anyway, okay, that's probably enough about snap trimming. I don't know if I want to do it or not, but we'll see. We'll see when we get there. Do you want to talk about the latest C-Star fund, Greg?
Sure. I mean, there's not really any design to talk about here. It's more just a notification. So we've been talking for many years about how the multiple thread pools model of the OSD, where we hand off every operation between a bunch of different threads, which possibly means a bunch of different cores and mutexes across everything, is just, wildly insufficient for NVMe and fast storage, which, is not surprising since it was written for running on hard drives that could do 100 ops a second. And we're at the point where we think we're actually ready to do the work to change that because we think we have to. So I've been doing some research into sort of the C-Star model, and in the past, then Adam and Casey have done some actual work with C-Star. So they sent an email to the Ceph Devel list about a week ago titled "Fun with C-Star," and if How Am I Still Around? Then he responded to that. And he asked, are we really going to put in the work to like to rewrite all of the code? And the answer is yes. We're going to refactor all of the code, eventually. So there's still a little more sort of due diligence research I want to do. We've been over C-Star and we think that we can coerce it into doing the things we need to do. There are a few other features that other libraries for non-C++ languages have that I want to look at and see if we can coerce C-Star into adding them while we're doing everything else, and just make sure that there isn't and I want to just go out and make sure there aren't some new C++ competitors to it that we've missed out on. But it's probably going to be C-Star. What we're thinking is that Adam and Casey are interested in doing what they're calling a tame reactor, where they take sort of the C-Star futures stuff and as the framework exists right now, it wants to own the world, and that means both the program architecture. It has its own options parsing framework and everything else, and also basically the hardware. So that's not going to work for us. We need it to live inside of the Ceph frameworks, and we need to be able to configure very carefully how many cores it's running on, and have code that doesn't run inside of the C-Star framework running in the process. But Adam and Casey are interested in building a tame reactor, and so they're sort of going back to some of their work. And we think we're going to try and start off by plugging it in sort of inside the dispatchers. So the messenger will stay as it is, at least for the beginning, and we'll build sort of an OSD. We'll refactor the OSD code so that we can run just the normal I/O path inside of C-Star, and then pass it off into BlueStore file store at the bottom, and receive it from the messenger on top. And hopefully that'll have, and that'll build up enough of a framework to sort of show off that it's useful, and then we can start integrating more stuff. Probably the messenger will be the next one, actually, although I'm not super well informed on how the async messenger is set up these days. I assume since it has a DPDK system and that's part of C-Star anyway, that it wouldn't, and it's got its thread pools and stuff, that won't be too hard to put in, but we'll see. And gradually spread out to the other parts of the code. And that's got two big benefits. One is that, first of all, we will not, inside of BlueStore and inside of the messenger at first, then it will do whatever it wants to with threads. But at least inside of the main OSD, we will be stuck with the memory on one core and all the work happening on one core for every operation. And so that should be a lot less expensive, or it should be a lot more efficient with the work it's doing. And the other one, which I'm actually maybe more excited about, is that it will require us to be very, very diligent about the invariants and preconditions and postconditions of all the stuff we're doing as we turn it from sort of our blocking thread loop and waitlist models into futures where we just sort of have our chunk of work, and then the process this chunk once this condition is true, which is what model that the futures thing has, which means that hopefully it will be a lot easier for people to start doing productive work inside of the OSD, because it's more obvious what the rules are, and you need to be aware of less global state at any given time, which I'm also very excited about. So that is the plan we have right now. It's unfortunately the timing's a little weird. I was at a conference last week and I'm at another one next week, and Josh is on vacation and has been doing a lot of very customer specific stuff, but we hope to more or less sequester ourselves in rooms in December and after the holidays and make this happen. Make the core part of it happen. All of it, the whole OFD will take much, much longer.
I was gonna say, given the current state of probably async messenger is probably closer to moving towards that model, but the core of the OSD I see as probably as far away from that model as you can possibly get.
Yeah.
Which is not going to plug into BlueStore, the object store, which again is totally synchronous interface.
Yeah, so we have some nice barriers to that, so we can sort of Blue Store can do whatever it wants underneath us, and as long as we're behaving, then we should see some benefits. So yeah, the initial thing will very much just be the sort of read and write IO path, and then handing down to Blue Store, which will do whatever it does because it's got RocksDB and everything else.
If you imagine like the top, the middle, and the bottom, they can be different worlds, and there's a context switch between them.
But that's a lot better than having a context switch 3 times in the middle and on the way in and out, which is what we're doing right now. And I think it actually is 3.
What is the context switching right now? So with async messenger, does everything go fast dispatch now to OSD, or at least it goes to pre-decode where it gets to the PG shard, and then it goes to the right sharded queue.
Sorry. So we fast dispatch it inside of the async messenger thread. Then there's a crossbar into the
sharded
op queue. And so then everything on the way down does run inside of the same shard, but that actually might be one of 2 different threads. And it stops a lot and can go and listen back to
Wait, so
if you're lucky, it hits all the caches on the way down. It doesn't have to block until it goes into Blue Store. Prepares a transaction, and then there's another handoff. All the IO happens, or the KV sync thread picks it up, writes it, blocks, waits for the IO, then it wakes up again, and then there's all the completions where there are I think 2 context switches that have completion. But the main problem is that in the OSD, if you're lucky, you go from the sharded work queue crossbar all the way into Blue Store, but most of the time you stop because you have to go read the metadata for the object out of RocksDB, and so you block doing IO. And so you have other threads that run, and they're also blocking, and so hopefully you get enough parallelism to make up for it, but there's it's gross.
Yeah, so we're doing synchronous blocking reads in a lot of cases out of Blue Store into the main OSD code,
which then blocks the main
which blocks that thread.
Okay. So it seems like even before you get to Blue Store and things like that, when an asynchronous object store be already transitioning into this whole futures framework is going to be a huge undertaking. That's going to a multi-release undertaking, right?
Yes.
but bang for your buck if you're blocking processing in fast dispatch or in your PG shard thread.
No, you already need to. The amount of code to stop doing that would already be a huge refactor.
Yeah. But we have to block no matter what. We're blocking because you're doing IO. So the idea is to
No, the IO, it's still asynchronous. You get a callback saying it's ready, right? That's the future promise type of model, right?
Yeah.
But I'm we're doing the linear sequential stuff though. So we'd be you're right. We could switch to where our main thread loops can handle the asynchronous reads, and we'll go off and do something else. But then that's halfway to a real future already.
No, that's what I mean. But I think even before you try to transition, at the end of the day, transition the entire code to future promises, I think you're probably going to end up getting more bang for your buck, right? Because if you're already going to fast dispatch, it goes to the PG shard. Even
that's what I'm saying is that in order to do the refactor of that
promises, you're still going to do that. It's going to come in on one CPU core on messaging. It's going to say, oh, this PG is being serviced by that CPU core over there. It's going to get sent to a different reactor core on C star.
I think the hard part is refactoring the code so that you're progressing through states, and so so that the code isn't written as a imperative list of things to do that might block. Once you've done that and broken into stages, changing the runtime isn't going to be that.
That's the good part. The C star or whatever implementation you choose to actually then power in the future, I think would be the quicker swap out as opposed to refactoring state machines from synchronous processing to.
Right. So all of the real work is in changing the way the code works already. So we might as well make it work nicely with the thing we know we want to end up in. It buys us very little not to do that.
It feels like the thing that we should focus on now is everything we know we're going to have to do get up to that point, right? So
anyway, I mean, we need to sit down and plot out a lot more of a map than we have. Like I said, this is really just a notification. It's coming.
No, I mean, I'm excited about it. I just feel like in terms of bang for your buck, I don't think you're going to, probably a lot of people spend a lot of time doing it, and then you won't see any improvement because it's still, now you just block the reactor and you're going to have to go send the work to a work queue.
The thing is, so like I said, we're just doing the IO path, which we would need to change anyway. And once we've done it, then we will probably actually get more effective parallelism because we aren't just trying to make it up by having a bunch of threads, but we'll actually be able to pause that ops execution and
but
then go on to another op.
But without the appropriate interface into object store to be able to say, do this work for me and call me back when you're done, you can't really pause that work, right? If you're saying, hey, go look this cache key up for me, or hey, go read that data for me, if it all just ends up to a blocking read somewhere.
I thought we did. I thought we had.
There was a patch at one point to do some of that, but it never actually got done.
All right. Well, I guess we have to do that too.
We do that. Yeah.
That's all I'm saying. I think finding your 5 or whatever interfaces into object store that are your heavy hitters for your easy IO path that you're spending all your time blocking on, like reads and writes and lookups or whatever. If you can just get like an equivalent of AIO or future interface for those.
Mm-hmm.
Even if on the other side in the object store you just have like a shim that just throws it in a work queue and says I'm going to do this synchronously.
Right.
Yeah.
Yep. But it kind of feels to me like the first step is to like have a whiteboard that covers an entire wall and like draw the sequence of calls through the maze that is primary log PG.
Yep.
Because there's like do-op, prepare transaction, execute context, finish context.
At least on the happy path.
Right, because it's just a maze. Like when does the PG log update happen? When does the ops CTX pointer to the it's just gross, especially when you look at like half of it being reused by the cache sharing code. It's just, I think understanding what happens and like trying to like consolidate that so there's like a much clearer like beginning, middle, and end. That's going to make it better. So that when we have
the picture will not just make it better until we do something with the picture. But yes, I'm sure that will be part of the process. Like I said, there's still some due diligence we want to do before I actually go down this path. Just telling you, we're going to start doing this.
Right. Well, I think that part doesn't depend whether we use C-star or something else.
No, it doesn't. But I mean,
yeah.
No, we want to go to our new like asynchronous like future promise overlords, right? That's where we want to be. But how do we get there?
We are going to start putting real work into making that happen.
Yeah.
And there's some interest in getting at least the base done before Mimic because we need to get the base done inside of whatever release cycle we started in, or it's just going to be a disaster. And we don't really want to keep on building new features in.
It's never going to be able to be done in one whole release.
Not
regardless.
all of it.
So it's always going to be like I'm going to do like one chunk here, one chunk here, one chunk here.
That's exactly what I'm saying. The main IO path is our goal for this release. Not the peering, nothing else, just that. But
I'd even be happy if we could just document that maze that Sage was just talking about. Because that's, I mean, my gosh.
I'd be happy to. I want to get rid of the peering work queue so that everything actually finally is in one work queue. I think that's the next thing I want to tackle, because that'll cut out several hundred lines of code and a bunch of like grossness. But anyway, all right. I think Greg's audio broke. He's looking flustered. I see this look like so many times a day.
Someone tried to call me, and I got more ringtones than I expected based on the number of phones signed into Hangouts around me.
It's always exciting. All right. Do we have anything else we want to talk about? That's all we had on the agenda. Yep. All right. Cool.
Awesome. Thanks, all.
Yep. Thanks, everyone.
You guys.
Later, guys.
Thanks, guys.
Thanks, everybody.
Bye-bye.
Bye-bye.